everybody. I would like to welcome you to the National Center for Supply Chain Automation 2021 Virtual Symposium. We're excited to have you here. We had 548 people register for our event, so thank you for being one of those people. For those of you who do not know me, my name is Valerie Piper, and I'm the PI and Executive Director for our center. For those of you that I met last year in Atlanta, I was 35 days on the job. Today, I'm 417 days on a job, and what a whirlwind it has been. But I'm super proud of my team, of everything that they have accomplished this year, despite all of the challenges that COVID has brought on. This is also the 10th anniversary of our center, and this is a sort of virtual celebration, so to speak. We're excited to be able to provide you with professional development that will be informational, but also hopefully help you in your daily work. We have a great program laid out for you, as you can see from the schedule. We'd like to give a big thank you to our sponsors, Amatrol and Manufacturing Skills Standard Council, MSSC. We would not have been able to have this big of an event without you. I'd also like to thank Sheila Wilson and the team from Cord. This whole online event would not have happened without you. So we thank you so very much. If you are in ATE Center planning an event and need some support, we highly recommend them. We have several housekeeping items to go over. Please use the chat sidebar to interact, share resources, and ask questions, but make sure that you have selected all panelists and attendees so that everybody can see your responses. Please be sure that all of your communication is appropriate. You can also turn on closed captioning or go to the link in the chat and open it on your laptop or phone if you would like. Also, you will be receiving a brief survey sometime today and tomorrow, so please make sure to fill that out as it's helpful for us for NSF reporting. At this time, I'd like to introduce you to our symposium moderator, Dr. Mary Sampolsky. Mary currently serves as the PI for the NSF ATE Working Partners Projects and Workshops at Bellevue College. We're glad to have you here today, Mary, and thank you for all of your support. Please help me welcome Mary Slowinski.
Good morning, everybody, and thank you, Val. It's great to be here, and I'm really excited to have this opportunity to introduce all these fantastic sessions that your team has brought together for these next couple of days. But before we jump in, we'd like to find out where our attendees are dialing in from. So if you would venture over to your sidebar chat window, make sure that under the two, you'll see a two thing. Make sure that that's selected panelists and attendees, and then just post up where you're calling in from or viewing from. All right, Texas, there we go. We know Sheila's there. Oh my goodness, they're going so fast, I can't even see them. Oklahoma, Wisconsin, we've got Washington State, we've got Washington, DC, Wisconsin. I saw hi Mary go by, whoever that was, hi. All right, so if you haven't, we're really pretty much everywhere, aren't we? Alabama, Virginia, Maryland, California, another Texas, holy cow. Kitsap, Washington, that's close to my home. That's in this picture, actually. All right, so that's great. If you haven't posted, go ahead and feel free to keep posting in there. It's always nice for us to be able to look back and see where everyone came in from. And one other thing we're going to do before we get started, we'd like to know how you are associated with supply chain. So if we can show the poll, please, Trey. All right, you should see on your screen our question to you. The question is, in what area are you affiliated with supply chain automation or environment? So the primary one, we realize that many of you are in more than one, but if you just pick your primary one, and we'll let it go for a few more seconds, and then we'll show you the results. Keep them coming. Oh, it looks pretty close. I'm looking at our number of attendees and our number of responses. Yeah, Trey, go ahead and show the results if you would. All right, so not entirely surprising. We've got a heavy predominance of education training folks in the room, and that's terrific because what we've got scheduled for the next 2 days are gonna align perfectly with that. But they also will be covering a lot of these other items that we see on this list. So, all right, that gives us a better sense of who's in the room. So thank you again for your input. We're really glad you're here. And let's go ahead and get rid of that poll. And with nothing holding us back from getting going, let's do it. So I'd be pleased to introduce our first presentation. how valued workers can use autonomous mobile robots to improve efficiency and boost productivity. And our co-presenters for this are Jason Walker, who's the CEO and co-founder of Waypoint Robotics, and Patty Katsaros, Director of Marketing and Growth for Waypoint Robotics. You can see they've joined us on the screen. So one note before we launch, please remember to post any questions as they come up in that chat window. And remember to keep it selected as panelists and attendees so that everybody can see the questions you're posting. And we have set some time aside at the end of this to be able to look at those questions and get to what we can. So join me in welcoming Jason and Patty. Go ahead, guys.
Thank you, Mary, so much. We are so excited to be here from Nashua, New Hampshire. And we're excited to talk to everybody about autonomous mobile robots and how they're helping workers and the opportunities that are being afforded with this new technology being brought in. But we're going to start out with talking about what is an autonomous mobile robot. And for that, my teammate, CEO Jason Walker, is going to talk about that.
Yeah, thanks, Mary. Thanks, Patty. So when we talk about autonomous mobile robots, what we mean by that is that it's a robot that can perceive the world. It can make decisions about what it perceives, and then it can do something to act in the world based on that decision that it made. And AMRs do that by using onboard sensors. They have a computer on board, which is the decision-making capability, along with all the software. And then usually wheels and motors are the things that allow them to act on their decisions. AMRs learn their environment by creating a map. And so usually in the setup process, a person will drive the robot around, and while they're driving it, the robot will make a map for them. And that's the map that it uses to be able to navigate. And then while the robot's navigating, it is autonomously deciding what is the best path to go through the building, and can reroute and navigate around obstacles, go down aisle 6 if aisle 7's blocked. And the autonomous part of autonomous mobile robot, that's really what it means. It has the decision-making authority and the ability to act to achieve an objective instead of executing each individual little command. Something that looks kind of like that from a distance is older technology called automated guided vehicles. And the guided part of that means that there's something in the physical environment that the vehicle is following. So that could be a magnetic strip that's buried in the concrete, or some other kind of navigation aid. And these AGVs can only go where those lines on the floor are already existing. And so if you need to change the direction that the robot goes, or you want to change your workflow and you need it to go a different direction, AGVs are pretty much inflexible in that way. They can really only do what they're currently set up to do.
Okay, so that talks a little bit about what AMRs are, but how are AMRs helping workers? Certain ways that they can do this is they can reduce time-consuming, tedious tasks, automate loading and unloading of materials, reduce long walks, transport heavy and bulky materials, and essentially keep people safe and socially distanced. There's a lot of potential benefits for these AMRs, and so we want to go into showing you some examples of these applications.
So AMRs can be used for the most basic task of just moving something from A to B. And that could be where a person might have been pushing a cart before. They can put materials onto the AMR, and they can send the AMR to another destination, and it'll figure out how to get there. So that's an example of the AMR taking instructions directly from a person and controlling it. But sometimes you also want to be able to integrate them with other machinery or software systems. And so that's another way that movement can be initiated. But one of the things that's really handy is to be able to have the robots automatically load and unload materials. And for that, we use a variety of accessories, or we call them top modules. to automatically load and unload the robots. And this allows the workers to keep doing the things that only workers can do at each end without having to synchronize their activities with the activities of the mobile robot. And having those activities decoupled at the beginning and end of the trip makes the people at each end more efficient and the robots more efficient, so they can each work in their own time. And so this is an example of the Kingpin top module. It's a lift deck that can pick up and drop off totes. And then another way that you can accomplish that decoupled activity is to use a cart, and then Kingpin can also hitch to a cart and pull it around the facility. And it can carry a tote one way and move a cart back going the other way. And that decoupling of activities is one of the key benefits to having automatic loading and unloading. There's other types of material. For example, a conveyor is a very common thing you'd find, obviously. The same value applies here. So being able to quickly and accurately dock to a conveyor and then have the conveyor communicate with the fixed conveyor to exchange the tote or the box or whatever the material is. That again decouples the activity of whatever is supplying the materials and whatever is receiving the materials, as well as all of the people working around it. So the objective is to take those dull, dirty, dangerous, boring tasks and let the robots do them. The most sophisticated type of top module is a mobile manipulator. And this is a collaborative robot arm combined with an autonomous mobile robot base. And the best ones, like what we think we have a really complete integration of the two systems. And if they're really easy to set up, then this is a robot that can it can move in spaces and move in ways that people are already moving. And so if you wanted to, for example, automate mail delivery in a huge facility, this is an example of a robot that doesn't need a pickup and drop off station or a conveyor or a cart. You can use all of the things that you've already been using with a person and have the robot go pick up a tote full of mail and then drop it off at all of the appropriate stations without having to do anything additional to the environment. So another application is heavy lift stuff and things that forklifts have traditionally been used for. We've had a lot of requests from our customers over the years to try to reduce the safety risks that are associated with forklifts. It's kind of shocking how many injuries and deaths are related to forklifts. And it's not entirely surprising when the extremely long distances that a forklift has to travel are the least interesting and most high-speed parts of the job. And if you can concentrate the activity of forklifts in a certain part of the facility, and you can limit pedestrian traffic in that part of the facility, then there again, you're kind of decoupling activities and you're separating the people from the danger. And then you also have an autonomous mobile robot that doesn't blink, doesn't get bored, doesn't get distracted, and it makes the long trip through the facility. And our customers are always talking about needing more people. The workforce challenges are really driving all of this, and forklift drivers are a great example of a skilled worker that has a lot of valuable experience and expertise that are frankly hard to find and hard to retain when there's better offers. And so being able to utilize the great team that you already have for the things that only they can do, and then let the Mavic or any other heavy lift robot carry the big items through the facility is a big win. And I'm going to steal Patty's joke. You also get a free pallet wrapper with every Mavic you buy. So that's a good deal. This following video is a case study that we did with an e-commerce company. So this is a company that was already experiencing a lot of growth and needed to expand. And they ship medical supplies to older folks in their homes. And when the pandemic hit, talk about, essential business. Their business was just booming, and we were already in the process of deploying an AMR fleet in their facility, and that just really highlighted how necessary it was. So when they added the AMRs and the voice picking system to their facility, compared with their previous method of just using manual push carts, they were able to triple their picking efficiency and double the overall output of their facility with a 99.9% accuracy rate. And so they went from being barely able to keep up to actually getting themselves in a position where they're meeting all their promises to their customers and meeting all of the demand, and also positioned so that they can grow the company in a way they want to grow. This is an extremely scalable solution. The way it works is the voice picking system sends the robots and the people to the same destination independently. And when they meet at that location, the picker gets an instruction to pick a certain box and place it in a certain location. And then when they scan that code, the robot goes on to its next destination, and the picking system sends the person to their next destination. And so again, this decoupling of material movement from the things that humans are uniquely great at doing is one of the things that makes this such a powerful technology.
Okay, so we talked a lot about the potential benefits and benefits that AMRs can offer workers, but a lot of companies are still reluctant to adopt, and workers are a bit hesitant. And we want to dive into this a little bit more. So, we hear all the time that, and this makes sense to us, that workers push back when change is forced upon them. And like everybody, kind of often fear the unknown. When you have tools that they're complicated and not really made for them or with them in mind, they might hesitate and be fearful of the tools. We'll hear that they'll often resent these outside experts that'll come in and pretend, they might know the technology of the robot or the automation piece, but they don't know the company, the task, the job, the trade like they do. Those valuable workers that have been there and have such great expertise, they're going to resent those outside experts. And then they're going to naturally worry about job security. If a complicated tool comes in and they think immediately, we might get displaced, and especially lower skilled workers might have that. Data even shows that can happen. So if it's a complicated tool that's difficult to work with, they're they just understandably are going to resist and be fearful of change. So what can be done? So first, it starts with, so there's two parts of it. It kind of starts with the tools themselves. You have to think about, we very strongly believe that the automation tools like AMRs need to be designed with a worker in mind from the very start. We're thinking of that great worker that's on the job today that knows the job the best. So the features and functions from the ground up need to be designed with them to be easily deployed immediately, so that they can take it as soon as possible and embrace it and figure out how, and they'll be the best people to really figure out and use their expertise and use their creativity, figure out how these tools can improve the process and the workflow. They're going to be the best people to do that. So making accessible automation tools like AMRs, and if you can make it so you can put it in their hands immediately, that's going to be your best chance for people to feel comfortable immediately and to adopt and embrace, not just adopt, but really embrace the tools. And so how do you, so there's the aspect of the tool itself, but then there's, okay, now how do you get them involved in the beginning? And so we feel like you need to fully understand the worker's perspective, and to do that, you have to have honest conversations and about what the plans are. And as I said before, involve them from the beginning. So first, you want to explain why automation is necessary, how it's going to help the company, but actually, more importantly, how it's going to help them, how it can help them individually, and how it can be beneficial for them. Include the employees when they, ask the employees to help document the material handling functions. And you might be surprised, you might find things that you hadn't even thought of, where the employees might be have ideas on how these tools can be used, how the mobile robots or any other kind of automation tool can be used. Ask them about things that are the most challenging parts of their job, both physically and even psychologically, and you're going to learn their perspective, and the project as a whole is going to be even that much better. And then get their input as to what automation tools would improve their day-to-day. And then to do that, what's really helpful is when you have vendors come in, you want to have vendors come in, especially with AMR's newer technology, but include the workers and include your front line in those demos, and have them ask questions about how it's going to work and how it's going to improve the process that they know so well. And then you can have workers design tests based on their experience and best practices, and then work with the engineering team, whether that's outside team or inside team, to help to really help them create the process with the new tools. And then the testing criteria, part of the testing criteria should be, how do these workers interact with the robots, and how easy it is for them to interact with the robots. So if you think about easy to use tools, and you think about ones that are designed for workers, and you include the workers from the start, the wonderful thing about this new technology is that there's a lot of great new opportunities for workers of all skill levels to be involved in the automation future of the company. And so we put together some just with AMRs specifically, how workers could be part of how they could upskill themselves with these tasks that will need to be done for AMRs. So example, no code programming, so an easy to use robot that can be set up and use visual programming tools. The workers can do this. They're able to get the robot set up from the beginning. And then likewise, AMRs are designed to be easily reconfigured as your workflow changes, so the workers could be involved in that reconfiguration. Preventative maintenance is something that you want to think about for all types of equipment, and AMRs no exception. So you think about inspecting the hardware, cleaning the LiDAR lenses, running software updates are all things that will need to be done when you deploy autonomous mobile robots. And then connectivity, keeping robots and other warehouse equipment connected, monitoring network performance, eliminating sources of interference, all are things that need to be done and that workers can do when they're involved in the process from the start. And so we talked a little bit about, I talked about the importance of choosing tools that are accessible. And so we're going to talk a little bit about some features to look for specifically for AMRs. So features and functions, we want to find ones that enable fast setup and intuitive operation without the need of those robotics experts. And then you want to look for user-friendly functionality that is going to engage the workers from the start, as I mentioned. And Jason's going to walk us through.
Yeah, so what to look for in an AMR that delivers on the needs that Patty just described. they need to be easy to set up. And we mean easy for the shipping and receiving clerks, the assembly line workers, the warehouse workers. It needs to be easy for them to configure and reconfigure without having to go to community college. It needs to make sense to them. What we've done to address that is we've built our dispatcher software as the main interface when you're setting up the robot. We tried to look at the entire user experience of setting up an autonomous mobile robot and really think of every part of it that we could improve and we could do for the users to make it easy to set up. And with dispatcher, there's always a big green button that's probably the thing you want to do next. And so if you pick the big green make map button, then you use a game controller, which people are familiar with, to drive the thing around like a remote control car, and it makes a map for you. And then you can use dispatcher to set up keep out zones, which are just where you want the robot not to go. And then the red dots are waypoints, which is where you want the robot to stop. And then you can make a playlist of waypoints and the robot will be navigating just as fast as that. You don't have to get IT involved. This is something that when we do demos at customer facilities in the old days, and hopefully soon, we always had the frontline workers involved with us. And so that's the setup process. But then on the day-to-day operation, it also should be easy and intuitive. And so we've made Whistle as a product that has a familiar interface. This thing works like an elevator, and the setup of Whistle happens in the background while you're doing the previous step that you just saw. So you push the come here button, and just like an elevator, a robot shows up, and then you can put a package on it and push another button and the robot goes there. A lot of the technology that we've baked into our robots has intuitive usage and behavior at the heart of it. Like that's the most valuable part of it we get. And so when you're setting up a mobile robot, you either have to have a robot that can perceive the world in a way that makes sense to someone, or you have to really educate someone a lot about how the robot sees the world. And so we've given our robots 3D perception so that the robot can see the world in a similar way. And that means that the robot's going to do what the users expect. So it doesn't make sense to people that a sophisticated mobile robot couldn't see a pallet jack. But a lot of robots can't see a pallet jack. They can't see small objects on the floor. And because of that, you either have to give them a lot of training to know where to put keep out zones and what kinds of things it can't see, or you need a robot that can do that on its own. And then another key thing is maneuverability. It needs to not only see the world the way we see it, but it needs to be able to move in the spaces and in the places and in the ways that people move, so that when a person wants to have the robot do an activity, it's going to be able to do it in a way and in a place that they're used to seeing it done. Here again, if you have to explain the kinematics of a particular drivetrain, then you've already lost them. This needs to be a tool that they can drop into their existing facility. It can go into a work cell or a piece of machinery in any direction or any orientation, and it can do all of that automatically without having to have any kind of complex setup. So while these things are really cool from a robotics standpoint, the real value of it is how intuitive it makes it for the users. Batteries and charging are another thing that we're all kind of used to the burden of plugging in our cell phones every night and cordless drills and things like that. You know, the battery maintenance in our lives is something that's almost a constant subtask. But when you're talking about an AMR, it's not just about convenience, it's about readiness, and it's about the longevity of the product and the expense of maintaining it. And so we really wanted to try to take batteries and charging off the plates of our users. And so we came up with the end zone wireless charging system so that it doesn't have to be perfectly aligned. You don't have to clean the contacts and perform maintenance on them. You don't have to replace the contacts. The robot will dock itself when it's ready for a charge, and it has to get close to the transmitter. And if somebody walks by the robot and bumps it, and it becomes a little bit misaligned, it's going to continue to transfer power, and then it'll be ready to use when you get there in the morning. And the batteries will stay healthy, and the organization can count on that piece of equipment with, again, not having to train your workers about batteries and charging. Network independence is something that doesn't come up as often as it should. No offense to any IT folks in the room, but anytime anybody has to involve IT, it can add a couple of weeks to your project. And so we've built our robots to be network independent. That means all of the systems, all the sensors, all the intelligence, all the data that they need is on the robot. And that means it doesn't need internet access or even local area network access to do its job. And that means that, again, intuitively, a worker can get this thing, take it out of the box, set it up, and start doing real work without having to involve the IT department as soon as they get it. And that's a critical differentiator. You want to be able to get started quickly, but you also want to make sure that it's scalable. And so interoperability and communication with external devices and software systems is equally critical, but it shouldn't be dependent. Nobody wants to trust their livelihood to Comcast, and nobody wants to be handcuffed by a system that can't communicate with lots of different devices. And so these things are, we think, extremely important. And we hear a lot of feedback from customers of all sizes that network independence, whether it's because they've got a huge facility and it doesn't have Wi-Fi all over it, or because their corporate policies make it really onerous to get anything new on the network. This is something that's really critical, and people need to think about it. And obviously safety is critical. Having any piece of equipment that isn't safe is not a win. And so we've built our AMRs with a 3-stage safety system, and our embedded system has a safety kernel that was architected in the same way as personal transport systems. The way this system works is that independent of the navigation system. So the navigation system will sense obstacles, it will reroute, it will stop, slow down, steer around them. In addition to that, and separate from that, there's this wrapper of a 3-stage safety system. And the way it works is dual safety rated laser scanners monitor the area close to the robot. And if someone or something gets too close to the robot, the safety system overrides any software at the hardware level, and it limits the top speed to 0.2 meters per second. So it slows to a very slow rate of speed. And then if anyone or anything gets within the next circle close to the robot, then the decelerate to 0 function kicks in. And again, at an electronic hardware level, the system is putting on the brakes, and it'll wait until the obstacle is clear. And then the 3rd stage is the e-stop phase, where if necessary, power can be cut to all of the propulsion devices. And again, this is separate and independent from the navigation system. And we've architected this system that's in all of our robots ahead of the international standards that were just released. We built our robots to be compliant with those standards in anticipation of their release. So there's a lot of ways to measure ROI. And I'm going to talk about the ones that are harder to quantify, but really easy to understand. When you're a worker who has unique skills and talents, and you feel really good when you're doing those, and you're in the moment, you're in a flow state, you know, let's say you're rebuilding a transmission, that is a lot of expertise. It takes a lot of brain power. But then let's say you have to stop that and grab a 300-pound transmission and push it across the facility. That's not fun. We've heard that directly from people who rebuild transmissions. And they would love to not have to do that. It's not work they're proud of, and it's physically exhausting, and it wears out their bodies. And so if you're thinking about one transmission remanufacturer who has to do that, and another transmission manufacturer where the workers are only engaged in the work that they're most proud of, and they don't have to do that laborious, interrupting task, that's going to be better. If they can go home at the end of the day with more energy for their friends and families, that's better. And if they have longer, more productive careers and their bodies don't wear out, all things being equal between those two companies, you're going to go with the one where you've got all of those benefits. And so again, those are easy to understand, but people are not used to trying to calculate them.
Yeah, and likewise, companies, leaders who give workers those tools, those easy to use tools, whether it's a mobile robot or any other type of automation equipment, you need to look for tools that are designed for workers and are easy for them to use. Those ones that get those exciting tools, the companies will have an easier time attracting people and then also retaining them as they're keeping them happier day to day. And if you're, again, we hear this from workers, if they have these tools that they feel are for them, that they feel that the company is willing, they're investing in those tools for their workers, and they tend to be happier with the companies and want to stay longer. And then the companies themselves, they get the benefits of the automation that are that easy to quantify those benefits, but they also get the loyalty of an empowered and happier workforce.
Yeah, we hear that directly from workers. There's a big difference between somebody bringing in an automation tool to displace them, or it feels that way, versus one that's obviously meant for them. And it shows that not just that automation is the future of the company, but those workers are also the future of the company. All right, let's take questions.
Thank you very much.
Okay. This is where I come back in. All right, so we had some come into the chat, and we also had some come in via message to me. So I'm going to start off with the first one. What basic skills should we be teaching future supply chain technicians to prepare them for working with AMRs in warehouses and manufacturing plants?
Basic skills. So I think generally speaking, any kind of computer interaction activity is good. They need general exposure to computers because they're going to interface with them no matter what. The tools that we've used, user experience tools that we've used in our systems, and a lot of other companies have tried to use similar tools, although we think we've done it better. A lot of the activities and tools that they use in STEM now, in science, technology, engineering, math education, a lot of the robots look a lot like those toys and those tools. And we use a game controller, right? And so when we were growing up, it was like, what are you going to do with your life playing video games? And well, I'm gonna herd robots. Yeah, so I think that understanding those things, a lot of the kids who are coming up in this time with those tools and exposure to them are going to already sort of be immersed in it. But I think the thing that's really great to reinforce is that it matters, and that if they pay a little more attention during the Scratch programming lesson, that's actually going to pay off.
Okay, we had a related question come in. Michael Galloway actually asked, does your company have any simulations that might be incorporated into college level classes?
Well, we have a simulator that is built for integrator partners or software development partners. That it's basically an integration target. And so this is a simulation of our dispatcher software, and it includes a 3D simulation and a virtual 3D world of a robot moving around. And we're not necessarily using it for physics and for load balancing. The purpose of that simulator is to enable our customers to get started with integration well in advance of the robot being delivered, and in parallel, and be able to work out any new or new integration with software ahead of time. So yes, to simulator, it isn't currently something that's integrated into college courses, but we are working on that.
And what skill sets maybe what skill sets are needed for software development in terms of the robotic software development? Is there any specific things that you recommend there?
Well,
Scratch.
so
Yeah.
so one of the cool things about Vector, and it's interesting because when we were building Vector, one of my former teammates at iRobot, a guy named Z, started a company called Root Robotics, which was later acquired by iRobot. And the way Vector works is you make the map, you put down the waypoints, and then you can make a playlist. And that playlist is something everybody already understands. What's cool though is you can save the playlist as a program, and that program is a visual programming language. So if you know what the playlist does and you can look at the visual programming language, you can kind of teach yourself how the visual programming language works, even if you haven't had exposure to it before. And then there's a third step, which is a coding interface, and it's a Python code interface. So for really advanced users, they can use the Python they already know, but if you don't know Python, you can know what a playlist looks like, you can know what a visual program looks like, and then you can see what the code looks like. And so you can almost teach yourself. And so this Root robot, this educational tool that Z built with his company, it works the exact same way. And we did it totally in parallel. And iRobot actually does have a simulator on their website.
I was gonna say, I can attest to being able to program without having any kind of experience programming, not coming from a STEM background. It was very easy when I started working with Waypoint to learn using those tools and to be able to start doing my own programs. So yeah, I can definitely attest to the ease of it.
Okay, so one sort of related question, is it really that easy to set up and operate your robots for the end user?
We think it is. Do you want to take this?
Yeah, I mean, it really is. There's a big green button that kind of takes you through, and then there's a lot of visual cues that are showing what's happening when the map is being created. And then the big green button to help guide you. What's the next step in the process? It's very easy to get it to where it's moving from point A to B, fully autonomous, and with the ability to navigate around objects. It is very easy.
Yeah, and I would, as an anecdote, when we go out to do demos, as I mentioned, I always ask who is moving the materials now, and can we get them to come in for the demo and for the presentation? And I involve them. I have them looking over my shoulder, and if I'm really smooth, I'll hand off the tablet to them, and they can start using it. And at the end of a demo, they're in the room with us and with whatever automation engineers who might have brought us in. And I always ask them, does this make sense? Do you feel like you know how to use it? And in the course of a 20-minute setup and a 1-hour demo, the answer has always been yes.
That's interesting. Okay, and we have a couple other questions coming up around safety, but before we do that, I want to ask this question, which someone posted, and I'm scrolling back up. They said, do you know any techniques that human resource offices can use to help employees feel comfortable working around these autonomous robots? So kind of speaking back to the integration of these guys showing up on the floor with actual humans.
Yeah, I mean, I think it kind of going back to what we were talking about, the earlier you can get people, the workers on the front lines to have exposure to that. And so that's why we very much recommend they're part of even the evaluation process. Not after the robot's been chosen and purchased and ordered, but as part of the evaluation process, bring them in, let them know, explain why you're bringing in these tools, how it's useful for them, how it's going to help them. And then, hey, invite them to the vendor meetings and have them ask questions, because they really are going to be the best person to get that perspective of how it's going to be used in their world. Even more than the operations manager, we believe anyway, or we hear that too from people that we work with.
Gotcha. All right, let's address some of the safety questions. There's been a bit going on in the chat around this. Originally, there was a question about are there different safety regulations for these as opposed to someone posted that the robotic arms used to be housed in caged areas, et cetera. That was one question. Related were about the lowness to the ground. Do they, become a tripping hazard? So can you kind of revisit and give us a little more on safety and the regulations that you have to adhere to, or that are emerging perhaps as these emerge?
Yeah, so the safety industrial robots, that phrase, that name usually applies to huge arms that are bolted to the floor that are incredibly powerful, and they need a cage around them. Although Veo Robotics is trying to change that, but that's a whole other conversation. So they are very powerful, and they do need to be separated. In recent years, starting with collaborative arms, which are smaller, slower, less powerful arms with torque sensing and the ability to detect and prevent impacts or reduce the effects of impacts. The arms were kind of first to go into the space of exploring the idea of this is a robot that is working with people in the same place, in the same space, even one handing or holding for another. And AMRs have really turned into collaborative robots of a different sort. They are, especially when you look at Vector, it's a relatively small robot. And it's built specifically to be able to operate in the places that people are operating. And we've built a bunch of safety features into it, as well as specific tools to really amplify the collaborative capabilities of it. And the mobile manipulation robot with the collaborative arm on the collaborative mobile robot, one of the cool things about that is we integrated the 3-stage safety system with the arm. So if the robot docks to a machinery or a shelf where it's doing kitting, something like that, the robot can set up a portable safety fence. Basically, it sets up a safety laser zone, and in the same way that our 3-stage safety system will slow down and stop if someone or something gets too close to it. If somebody approaches the mobile manipulator, say from behind while it's doing kitting, the arm will stop moving and wait for them to get out of the way before it continues its job. And that's something that's already built in, and it's part of what makes it easy to set up.
Got you. All right, that I think answers most of the safety questions. So one last set of questions, because we're getting close to the end. Those Omni wheels, those omnidirectional wheels, how do they handle the debris and uneven floors? Do they require extra maintenance? And then a related question, what happens when it goes down? Who does the repairs?
Yeah, so I would encourage everybody to go to our website and check out the videos from our garbage patch. So we built a pen and we literally filled it full of garbage. Out of the trash can, soda cans, wires, packing materials, and we've done tests with plastic pellets such as feedstock for injection molding. So these are on the floor. These are like ball bearings, basically, and we put them all in the garbage patch, and we made a video of the robot navigating in, around, over that stuff. And the Mecanum wheels do great. They actually do better than other types of propulsion systems. And the why of that is a long conversation, which I'm happy to have with anybody. But so they're actually incredibly good at rejecting debris. I don't want to say they're perfect. There's always the magic grain of sand that's just the right size to get stuck somewhere. But we've actually been really pleasantly surprised how well the Mecanum wheels do with spitting out debris that one would think would get ingested into them. And because it kind of floats over the top of debris, we find that it's really easy for the robot to maintain localization. But we did design those wheels to be consumables. And anybody who has anything with a wheel and doesn't design it to be consumable is crazy, because they will eventually wear out. And so with the HD Vector, for example, there's one bolt per wheel. And so you can change the wheels on a Vector like a pit stop in a car race.
Yeah, no, so then who does the repair? I think one is encouraging that preventative maintenance, which we feel that the workers can be involved with. Again, if they're brought in from the start, they can help with the preventative maintenance. And then if there are some other higher level repairs, then it might escalate up. But I think if there's basic preventative maintenance, you can really avoid a lot of this high level repair.
Yeah, that's exactly the kind of thing that that we see future technicians and robot wranglers doing, right? If there's somebody who was pushing a cart yesterday, then they can be keeping track of 3 or 4 AMRs in addition to whatever high skill thing they really would rather be doing. And so you just have to keep an eye on the, on the wheels, the dust on the lenses, that kind of thing. And then, do basic maintenance. We did build it so that, the same user, the shipping receiving clerk, the assembly line workers, those are the people who can do that kind of maintenance.
Yeah. Well, that's awesome. Well, okay, unfortunately that hour flew by, and we're coming, we gotta say goodbye to y'all. Thank you, Jason and Patty both, for that inspiring and interesting session. That was really interesting. Lots of food for thought.
Thank you so much. We're happy to answer any other questions people have. If you want to send them to us, we'll get back to people.
And feel free to, you guys can look at the chat now that you're not in the hot seat and see if there's anything you want to respond to.
Great.
All right, everybody.
Thank
So next up, thank you guys. So next up, we've got a short little video entitled, "What is a supply chain technician?" Then we're going to take a short break, and we'll come back at the top of the hour and hear from the supply chain panel. And that'll start up at 1 p.m. Eastern. So here comes a video, and then we'll see you back at the top of the hour.
A number of distribution and warehouses no longer just have forklifts and clipboards. They use robots and lasers and radio frequency identification tags and a lot of complicated systems, and we're looking for individuals like you to help run these machines.
Do you ever wonder who maintains this incredible technology? Today we are going to hear from some of the top supply chain technicians in the field.
You'll need to understand how computer technology controls the mechanical functions of the automated system.
Yes, I used to work in production. I did it for 10 years. I picked boxes, threw case on the line. I decided to go back to school. Got a technical training for 2 years. Maintenance had an opening. I applied for it, and I've been here ever since.
If you're a person that likes to fix broken things, then supporting the supply chain companies is the thing for you.
I worked for production for 8 years, and I got a chance to go to school, and now I got a better job with better pay.
In the next 20 to 30 years, there's going to be massive growth for technicians who can work on automation that is far beyond their imagination today.
Yeah, in my 40 years in the maintenance field, I've only been out of work 2 weeks.
My favorite part of the job is to come in and solve the problem.
Electrical is very important in maintenance because without it, you cannot troubleshoot it or repair it.
We got certain responsibilities in the building, in our plants, and we work in these responsibilities. But there is other people working in pneumatics, working in mechanics, working on electrical, electronics, AC, you name it.
As training and development manager for a large supply chain company, I can tell you there are many high-paying jobs available for you.
Every day I come to work, I do something different. I do electrical, I do airlines, batteries, forklifts, etc. It's never one thing.
If you've ever taken anything apart or have been interested in building robots and computers, then we're looking for you. There's high-wage, high-skilled jobs in automated systems.